So this is a challenge problem. It involves calculus, which is great. So it tells us that f(x) of t equals k1 plus k2y, and that fy of t equals k3t. And it wants us to calculate the position vector and the force vector. So we know we're going to have to do some calculus, and we're going to be taking the integral. So because f of y is already in terms of t, we're going to solve for f of y first. So this is what you do. Not the force. We're going to find the velocity. So because this is force, we know that force equals mass times acceleration, always. And so we're going to have to take the force divided by mass in order to get the acceleration. So ay of t equals k3 of t divided by m. Taking the integral, we get vy of t equals k3 t squared, and then we divide by 2m. And to get the position of y in respect to t, we get k3 times t cubed divided by 6 meters. Because when you take the integral, you add 1 here, and you divide by the 3. So that was how we got from velocity to initial. So now we know what y of t is. We can solve for x. So again, the a of x of t is going to be k1 plus k2 times this y, which is k3t cubed over 6 meters. K1 is also over 6 meters, and this is meters squared. Because we divided both of them by meters, and this already had a meters in it. So now when we get the velocity in the x direction, we take the integral, and for the first section part of this is k1 times t divided by mass. And for the second part, we get k2, k3, and t to the 4th divided by 24 meters squared. Or mass squared. Because we added 1 and we multiplied by the 1 we added to get 24. And now for the x in respect of t, we get k1 t squared over 2 times m plus k1 k3 t to the 5th over, so 5 times 24 is 120 meters squared. So now we have the x and y components of each, and we know that our variables, so for our position vector, we're going to have x k1 t squared over 2m plus k1 k3 k2 k3 t to the 5th over 120 m squared I hat plus r k3 t cubed over 6m j hat. And that is a position vector. And then the velocity vector is just what we have up here. So for the x, it's k1t over m plus k2, k3, t4 over 24 meters squared I hat plus what we have for the velocity y component, and that's k3t squared over 2m j hat. And that is the answer.